Thanks for tuning in at Brackeys.
Hello everyone and welcome to the third video in the How to Make a 2D Platformer course. Today we're going to be taking a look at how to achieve the parallaxing effect that you see in most modern 2D games. So parallaxing basically means that the foreground and the background will scroll at different speeds, which will allow us to create depth in our game. And when I say depth, many people get confused because they say, well, it's a 2D game, how can you have depth? And it's true that we aren't actually creating depth because we are using an orthographic camera, which before it renders stuff will align everything on the same point on an axis, but it will allow us to cheat a bit when we see them scroll at different speeds in relation to the camera. So please bear with me. Once you see it working, it shouldn't be that difficult to comprehend. Awesome. Before I get started, I just want to quickly say that I'm looking for someone to do the character design because I'm not that great with drawing. I mean, the environment in itself was challenging enough. So if you are good with a pen in any way or just up for a challenge, please write to me. The email and subject line is on the screen, or reach out to me at Twitter, at Brackeys Tweet, or on my personal Facebook, which is in the description. Cool. So that was the longest intro yet. I think let's now get started. So as always, I've opened up Unity. And right now when we hit play, you will notice that everything moves in the same speed. And this is not really something that we would like. So let's go ahead and change this with a script. So this is going to be our first script in this series. And please note that this is not the easiest script. If you have never coded before, maybe check out the Mega Game course or the Going 2D one. So we're going to go ahead and create a new game object. It's going to be an empty game object. So let's press Ctrl-Shift-N. And let's rename this to _GM. The underscore will make sure that it's always at the top of the hierarchy, and then GM for Game Master. I like to center this just so we know where it is. And now let's hit Add Component, New Script, and then change the type to C#. And let's rename this to Parallaxing. Yeah, so now hit Create and Add. And now we can double click it to open it up in MonoDevelop. So MonoDevelop is Unity's built-in script editor, but feel free to use anything you want. Whoops. Let's try and open this up again. There we go. It's Unity's built-in script editor. MonoDevelop does a lot of other stuff. It's great for C#, I find, especially with the new version. It's also gotten a lot prettier with Unity 4. But you can also use stuff like Notepad++ or Visual Studio. Yeah, so feel free to choose whatever you need. Cool. So now let's go ahead and first off declare some variables. So we're going to keep the start and the update functions because we're going to need them in just a sec. So first let's create an array that will store all of the elements that we need to apply parallaxing to. So we're not going to apply parallaxing to the middle where our platforms are going to be and where we're going to have all the gameplay stuff. That would be way too complicated. We're only going to apply parallaxing to the background and the foreground. So now let's create a public transform, and to make an array, meaning a list of objects instead of just one single object, we're going to do an open and close square brackets, and now we can name it. So now we can just do, let's just do backgrounds for short, and close it with a semicolon. This is also going to store foregrounds, but else we would have to do elements, and yeah, backgrounds is just simpler. So this is our array, meaning a list of all the back and foregrounds to be parallaxed. Awesome. Now let's create a private float, and this is also going to be an array that are going to store all of the parallax scales, meaning the proportion of the camera's movement to move the background spy. And we're going to automate this so that we don't have to apply a value for each one of these elements, but we can simply just move them back and forth and on the z-axis, and then the script will take care of everything for us. So we don't have to guess how far it's gonna back it's gonna be. We can simply move it on the z-axis. So to do this, we are gonna have a list of the object scales. So let's call this parallax scales. You could also call it amount of parallaxing or whatever you want. I'm gonna call it scales. And this is again the proportion of the camera's movement to move the backgrounds by. Awesome. Just under this, we're gonna do public float, and this is just a symbol float value, not an array. And we're gonna call this smoothing. You could also call it parallaxing amount, because it's pretty much what it does in reality. But in theory, what it does is smooth it. So this is how smooth the parallax is going to be. Make sure to set this above 0, or the parallaxing effect will not work. So by default, let's set this to maybe 1, just to make the effect really apparent. Cool. So that was it for our top variable declarations. Now let's do a private transform, and we're going to call this cam, and this is simply just a reference to the main camera's transform. It's general good practice to store this in a variable, because it will first of all be faster, and also it's just easier in writing to just read through it when you have a short name for it. Cool. And then we're gonna do a private vector3, meaning a tuplet, meaning a x, y, and a z value. And we're gonna call this previous cam position. And this is going to store the position of the camera in the previous frame. And this is what we're going to use to do the calculation of parallaxing. And the calculation itself is not something you need to understand. It can be hard to wrap your head around, but please just write this after me, and we'll look into understanding it further later, or you can always look up the effect. Cool. So now let's create a void awake function. Whoops. Awake. And let's open up some square brackets here. Oh, not some square brackets, curly brackets, I mean. There. Cool. And the reason why we have both an awake and a start function is because I wanted to explain to you the difference of the two. So the awake is called before start. And what it does is it will call all the logic before the start function, but after all the game objects are set up. This means that it's great for assigning variables like the camera here, so just assigning references between scripts and between objects. So great for references. Awesome. I try to comment out a lot of the code I write, both so you can read it afterwards, and also just so you can quickly look back if you don't get my verbal explanation. So I hope that's okay. Now we are gonna set up the reference, the camera reference, reference, set up camera reference. And we do this by writing cam equals camera.main.transform. We could, of course, just make this a public transform and then drag in the camera inside of Unity. But this way we just select the main camera much more easily, and we make sure that we always remember to do this because we don't have to. Awesome. So the start is used for initialization, and that's what we're going to do. We're going to initialize our different variables. So first off, we're going to say we're going to store the previous frame. So the previous frame had the current frame's camera position. So we're going to do previous campus equals cam.position. So this way we assign the previous cam position to the position of the camera just when starting out. And again, please just ignore this. That's just something we have to do. And then what we're going to do now is we're going to loop through, meaning that we're going to take the backgrounds list here. It's technically an array, but I will call it list. And we will take every element in it. We'll say, hey, you're an element. And then we will assign that element a parallax scale. So basically what we'll do is we'll say that the parallax scales list is going to be just as long as the backgrounds. And then we're going to loop through all of the backgrounds and assign the z value to the parallax scales. So we're going to do this in the start function. And what we're going to do is we're going to type parallax scales. Why is this not working? Let's try this again. Parallax scales equals. Have I written? Yeah, I forgot to write this with 2 L's. So let's try this again. You were probably thinking this all along. Parallax scales equals new float. And remember the 2 square brackets. And then a semicolon. And inside these square brackets, we can declare a length. So what we're doing here is we're simply saying that the parallax scales should be an array of this length. And the length is just going to be backgrounds.length. Awesome. So whatever we set the backgrounds to be, we are going to get the length here. And then we're going to loop through them. So for int I equals 0, I is less than backgrounds.length, I plus plus, and then open up the square brackets. Or I keep on saying square brackets. I of course mean the curly brackets. Cool. So what we're doing here is we are using a for statement to iterate through. And what we do is we make a variable called I, and we set this equal to 0. And we say that as long as I is less than the length of the backgrounds, we're going to keep on going. And every time we have looped through this, we are going to set we are going to increment I by 1. So this will be called as many times as the background.length is long. And what we can do in here is we can set the parallax scales. And then inside the curly brackets, we're going to do I equals backgrounds. And then inside the curly brackets, we're going to do I again. Dot position dot z. And then we're going to do times -1 just because that's something we need to do. You don't need to worry about that. Just make sure that the times -1 is in here, or we're going to get the opposite effect of what we want. So what we're doing here, again, to summarize it, is we are making sure that our parallax scales list is just as long as the backgrounds. Then we are going through each background, and we are assigning that background set position to the corresponding parallax scale. Awesome. So that was basically it. And again, you don't need to get all of it right away. But I'll just say here that what we're doing is we are assigning corresponding parallax scales. Cool. Then in the update function, we're going to get to write the actual logic here. So what we're going to do is we're going to write another for statement. So for each background, we're going to do this. So for int I equals 0, I is less than backgrounds dot length I plus plus. So that's the exact same statement as up here. We're simply looping through the backgrounds and then the curly brackets. And in here, we're going to first off say that the parallax is the opposite of the camera movement because the previous frame multiplied by the scale. So we are saying float parallax equals previous cam position dot x minus cam dot position dot x times the parallax scales I, and close it off. So what we're doing here is we are saying that the parallax in effect should be the difference between what our camera's position is now and what it was before, meaning how much is moved. And then we are gonna time this by the amount we want the parallaxing to be. So this is that value of the background. That's basically all we're doing. We are taking the movement and we are applying it to a value and multiplying it by the scale. Awesome. So what we can do now is we can we can set a target x position, which is the current position plus the parallax multiplied. Let's just forget that, plus the parallax. Awesome. So we're going to do float background target position x. So we're making a new variable here equals backgrounds of I dot position dot x plus parallax. So we are just saying that the new, we are taking the parallaxing and we are applying it to a actual position. So we are storing the background target position x. In this variable, we are storing the position of the background plus the parallaxing. That's all we are doing. And then next up, we can create a target position with the actual x position and the actual y position. So we can create a vector 3 here. So let's do create a target position, which is the background's current position with its target x position. So we're doing vector 3 background target position equals new vector 3 background target position x for the x value, and then we're just setting it to the y and the z of the background. So backgrounds I dot position dot y and backgrounds I dot position dot z. So basically all we're doing here is, first off, we are making a variable for the x value, and then we are adding this to the target position, which is just a vector 3. So it's just going to assign the background target position on the x and then take the same y and the same z as it had before. We could also do this on the y, but since we are not going to be moving too much up and down, I think that we will leave this out so far and then maybe add it in later. That's a challenge for you. If you can figure this out on yourself, please go ahead and try it out. But it's not something that we are going to add right now. I think this is more than plenty, and I know that this is maybe too difficult for some of you, but please note that you can of course get this script from brackeys.com should you be lost, and definitely not all of the coding that we are doing is going to be this hard. This is pretty much the peak, I hope. Cool. So then we are simply going to lerp, meaning fade, between the background's position and the new target position. So fade between current position and the target position using what is called lerp. And we do this by saying backgrounds of I dot position equals vector 3 dot lerp. So vector 3 has a lerp function built in, allowing us to fade between positions, and that's really awesome. So inside of this, we're going to fade between the backgrounds I dot position, so our current position, and the background target position. And we're going to do this using the smoothing effect times time.delta time. And time.delta time is hard for some to understand, but basically all you need to know is it converts frames to seconds. So instead of doing this by frames, meaning that if your computer was running this really well, the background effect would be all kinds of crazy, that we're doing this in seconds instead. So we're gonna round this off, and yeah, cool. Then at last, when we get out of this for statement, we're gonna set the previous cam position to the camera position at the end of the frame. So we're gonna set the previous cam pos to the camera's position at the end of the frame. And we could do this by previous cam position equals cam dot position, just as we did in the start function. That was all. Okay, so if anyone's still watching, that was basically it. So now we're going to hit save, and we're going to take care of all the errors. This might be the first time in tutorial history that anyone has done parallaxing without errors. Something has got to be wrong, but let's try this out. So what we can do now is we can actually set this up. And if you've downloaded the script, this is where you should tune in, because now we're going to actually achieve this effect. So let me just check how long we've been recording here. Wow. Okay, so this sure was a long one. Might need to split this up. Cool. So now on this parallaxing script, you can see that we have an array here, which we can adjust the size of. We're going to set this to 3 because we want both the background mountains, blue and purple, and the foreground dirt. So now we have 3 elements in here. And please note that whenever you're setting the background size, Unity will sometimes not allow you to do this. If you put in a number and then click out, it will just cancel. So write 3 and then press enter. The smoothing, we are gonna just leave this at 1 for now to just see how the effect works. And then we're gonna tune it down a bit later because this is going to be a bit too crazy, I believe. Awesome. So now let's just add the different elements, and it doesn't really matter which order they're in. So just drag in the background mountains purple, the background mountains blue, and the foreground dirt. And we're going to hit play. And you're going to notice that this is not at all working. And that's because we have to also adjust the Z position. And this is the really cool thing about doing it this way with all the arrays and stuff, is that we can actually just select the different elements and then move them back in relation to each other. So we're going to move this almost as far back as the blue background, just in front of that. And we're going to take the purple one and we're going to move it also pretty far back, but a little less. So something like this, I believe, would look pretty nice. And then we're going to take the foreground dirt, and let's just see, where's our camera. It's there. You can, of course, view this from the left side if needed. I'm going to do that. And we're going to just move this over. If you click on this cube, we're going to change. Whoop, that's not going to work. Never mind. Okay, so let's just move this over so it's not behind the camera. It will not appear, but just in front. And let's hit play and see how it works. So now when we move, the layers will move accordingly. And this actually looks really cool, I think. This gives it a really nice effect. You can see that our foreground is moving faster than the middle here, and the background is of course moving slower. So that's awesome, and we still have a little bit of parallaxing occurring between the two background layers, which is pretty awesome. So I might go ahead and bump this effect down a bit, and might even see, if we select the camera here, how far we can push this. Nah, this is as far as it's gonna get. That's of course the only thing that might be annoying about this technique, but is that you have to still be inside the range of the camera. But in order to change this, you can just change the smoothing and then simply adjust them afterwards. So let's try setting the smoothing to 10 just to see how it looks, and this is going to be pretty extreme. You can see this is what parallaxing does when it's way too high. That doesn't look nice at all. But maybe something like, let's try 0.5. That's too subtle. Let's actually try maybe 2. And again, just play around with this until you find something that works. This is too extreme. I think I'm just gonna go with 1 for now, and then we can always change it later. But that just added some real nice depth to the game. So I hope that you're pleased with the results. We still have some things to take care of. For example, the looping of the ground here right now, it's cutting off when you get too far to the right. We have to adjust some colliders. There's the whole player thing. Plenty of stuff to do. It's all going to be much easier than this, hopefully. And yeah, thank you for watching, and I'll see you in the next video.